to talk about two types of compound inequalities, and one of them is called an intersection. You can see on the top here that we have a Venn diagram. You've seen these before, where there's a region that overlaps. So let's look at what the two statements are here, and they are right here. So we have two statements, and if we consider them together, they share some solutions. So x is less than 10, and x is greater than 0. So on the left side here for A, they have some numbers that are less than 10, and then for B, they've got some numbers that are greater than 0. Now some of those can overlap. 1 is less than 10 but also greater than 0. 2 is less than 10 but also greater than 0. 7, 9, all of those fit in to that middle section where there's some overlap. And here's what we end up finding out. There we go. Alright, this can be graphed. So if we look at just the x is less than 10 graph, that is right here on the top. Anything less than 10 would be not including 10 and less. And then if we go to the second part, anything greater than 0, but not including 0. Well, we're going to look at where do these overlap, and their solutions overlap right in here, okay? So together, if we look at them and combine them, we get this statement. X is greater than 0, and x is less than 10. So we have two kind of statements going on. So this is what we would call an AND statement, and those are associated with intersections. So x is greater than 0 and x is less than 10. And that's how we would graph that. And you saw that on the first video. So let's look at what's going on here. We can solve these compound inequalities in two different ways. The first way is we can separate these intersections completely. So for instance, if I'm looking at A here, I can take this part and solve this separately. I can say, okay, well 4 is less than or equal to x plus 2, and then I can take this part, x is also, or x plus 2, is also less than or equal to 8, and I can solve both of these equations separately. So if we do that, subtract 2, and I'm left with 2, and x is greater than or equal to 2. Same thing to solve here, subtract 2. We've got x is less than or equal to 6. Now, all we have to do here is kind of check this out. If we were to graph x is greater than or equal to 2, we could do that. We'd find 2 and then graph anything greater than that. Same with x is less than or equal to 6. We'd find 6, and it would be anything less than or equal to 6. Now you can see that these two are eventually going to meet, and there's going to be values in between that also fit for both of them. And we're looking for the intersection. Where do these two things meet? So when we graph this, we got to consider both things together. So if we go to x is 2 and 6, we know that x can be 2 or greater, and x can be 6 or less. They're going to meet, and our intersection is right here. So really, I would just graph this thing as such. There is that intersection. Now the overall answer for the solution would be x is greater than or equal to 2 and less than or equal to 6, and we can just leave it just like that. Much faster way to do this, consider the whole thing together, alright, which is kind of weird, but you've got three different sides going on here. You've got the left, the middle, and the right side. Subtract 2 here, subtract 2 here, subtract 2 here. Now I'm left with x in the middle, 6 over here, and 2 over here, and there's that solution we were just talking about. X is greater than or equal to 2 and less than or equal to 6. I'm going to show you how to do that on the last one here, and that'll be it. So it's kind of like solving two equations at once. You're so awesome. Subtract 3, subtract 3. We've got 2x left, 6, and negative 8. Alright, and then we're going to divide by 2. And here's what we're left with. -4 and x and 3. Now our graph, so this is our solution. Our graph, we would find -4. This is not going to be the best graph. Let's say -4 is here, and 3 is up here, and 0 is in here somewhere. Sure. Okay. And we are stuck between those two values. We're including -4 because, as we can see, x is greater than or equal to -4, but it's going to be less than 3, and any number or value in between will suffice. All right, and there we go. And we can always go back and check that. So, for instance, choose a number that's in there. So 0 is part of my solution. Let's see if it works when I plug it in for x. 2 times 0 is 0, and then 0 plus 3 is 3. And we'll see if the statement makes sense. Well, 3 is less than 9, and it's also greater than or equal to -5, so it looks like we're good. All right, that's all I've got for intersections.